Hello my students, after that short break, let us proceed. And at this time we're going to look factor affecting velocity of sound in air. After knowing on how we can calculate velocity of sound in air, which is Laplace collection formula, we are going to look factors affecting. We have several factors and I can mention them here. One, we're going to look density. Second, we're going to talk on temperature. Third, we are going to talk on humidity. Fourth, we are going to look on wind. Fifth, we are going to look on pressure. And we are going to close up the discussion by talking about frequency. To begin, let us try to look how density affects the velocity of sound in air. I think everyone knows what is velocity, knows what is density. Therefore, my discussion will go very fast and quick. Let us assume the density of the media is increased. The density of the media is increased. The increased density of the media indicate that there is decrease in volume of that media. Why? This is because density is equal to mass over volume. Due to this, density and volume are inversely proportional. Now, if volume of the media is decreased, the decreased volume of the media tell us what? Tell us that the media has less number of particles. Particles are less. Particles are less. This one means less particles. Now, if there is less particles, what does it mean? This means that if we have less particles, this means that vibration is also less. Particle vibration is less. Now, what does it mean? If the particle vibration is less, hence velocity of sound in air, hence due to less vibration, this indicates that the velocity of sound in air is lowered. Therefore, the velocity of sound in air is lowered if there is high density, and will be increased if the density is low. That means the vice versa of this one is correct. Now, due to this, we have the following. We want to treat now this effect mathematically. Mathematically, we know velocity of sound in air and density, they're inversely proportional in this way. Now, if this is the case, for two gases, what are we going to have? We're going to have V1 of V2 is nothing but under root of, remember, V1 density of 2 of density 1. Why this? You see, this is not density 1 over density 2. It is density 1 of density 2 over density 1, because the velocities is inversely proportional to square root of densities. This is how you can calculate the velocity of any gases if you have been given different densities for them. But again, you have another factor which affects the velocity of sound in air. This factor is called temperature. I think you know the effect of temperature to the media. When you increase temperature to the media, that means you increase vibrations. There will be vibrations. That means you increase vibrations. Now, what's happened when vibration increases? When vibration increases due to temperature, that means that there will be what? There will be high sound wave transfer, or faster sound wave transfer. Therefore, sound wave transfer faster if temperature of the media increases. And now we have a question which supports this one. This question is saying during summer season, sound wave travel very faster than what? Winter. The question is why during summer sound wave travel very faster than winter. Why? This is because during summer there is high temperature. High temperature increases vibrations of particle. Due to the increase in vibration of particle, sound wave travel very fast. This is why during summer sound wave travel very faster as considered to winter where there is low temperature. That one will be asked and you will answer it that way according to the case of temperature. Now we want to treat temperature mathematically. We want to treat the effect of temperature mathematically. Mathematically, V and T can be treated this way. Velocity of sound in air is directly proportional to the square root of temperature. This is the question which you should know. Velocity and temperature are related with this question. The velocity of sound in air is direct proportional to the square root of that temperature. Look here. Why? Remember, temperature, increase in temperature increases the velocity of sound in air. Therefore, they are in direct proportion, although this is in a square root. Now, for two different temperature, what does it mean? We'll have different speeds. We'll have different what? Speed. Because speed depends on temperature. Therefore, if you have two different temperature, automatically we have two different speed of sound in air. Yes. Thus, what are we going to have? We're going to have V1 of V2 equals to under root of T1 of T2. V1, V2 is nothing but under root of T1, T2. This one is very common. But in your calculation, remember, a big note to note. In your calculation, T1 and T2 are used as absolute temperatures. Make sure you put T1 and T2 in absolute temperatures. Absolute temperatures. Do you know absolute temperature? That means make sure T1 and T2 they are in Kelvin units. Make sure if you have been given T1 and T2 in degrees Celsius, you change it by saying T1 equals to the given value, which is T in degrees Celsius, plus a constant 273. By doing so, you'll be changing the value given into Kelvin. And here is an example. Here is an example to support, to deal with this part here. The question is saying, at what temperature will the speed of sound in air become twice the speed of sound at 27 degrees Celsius? What is the value of temperature where the speed of sound in air, the speed of sound in air will become twice the speed of sound at 27 degrees Celsius? Now look here, we have been given the following. We're going to start with given. At what temperature will the speed of sound in air become twice? Therefore, V2 will become twice V1. Become twice. The speed of sound at T1 is 2, because V1 is the one which has T1, is 27 degrees Celsius, which is equal to 300 Kelvin. I said you must change this one to 300. And the question is asking, what is T2? What is that temperature? Solution. Recall from the formula, V1 of V2 is under root of T1 of T2. V1 is not given, therefore we can just write V1. V2, sorry, let me use here. V1 is here. V2 is twice V1, therefore there is no need of writing V2. We can write twice V1, therefore V2 is twice of V1. This is equals to under root of T1, under root of T1. T1 is 300K divided by T2, which is a known value. Now look, V1 goes out. If I want to omit under root, I'm going to square on each side. Hence, I'll have 1 over 4 equals to 300 Kelvin T2. Now, through your calculation, you get T2, which is the second temperature, is what? 1200 Kelvin, which is equal to 927 degrees Celsius. Therefore, as you can see, look here. Do you see at 3 Kelvin, V1 was equal to 300 Kelvin, V1 was equal to V1. But at 1200 Kelvin, V2 is twice V1. What does it mean? This means that when the temperature increases, the speed of sound also increases. When the temperature increases, the speed of sound increases. You'll meet with different questions as this part concerned. But remember to change the temperatures given into absolute temperatures, which is into Kelvin, before starting substituting into your formula. See you after this short break.